Hi, welcome back. So in the last video, we played with Git in the terminal. We made this silly recipes folder. And in this video, we will go under the hood and try to understand what Git was doing in order to version control the recipes folder. So the first thing we did was call the git init command. Git init tells the computer, on this recipes folder, I want to have version control. In order to do that, Git sets up all the infrastructure it needs to operate. Specifically, it keeps track of two main types of objects. One object is the staging area, and the other type of object that Git will keep track of are commits. So you can imagine that these two things are created after we run the git init command. And if you want to see their real-life representation, we can go to the recipes repo and hit ls-a. -a means list everything, including files that are hidden. And we will see that there is a folder over here called .git. So any file that begins with a dot is hidden. We will not normally see it if we just do regular ls or use Finder to explore this folder. And inside this folder, Git will keep track of all these objects I just mentioned. Be sure to never, ever, ever actually go into this folder and change things because it will most likely break your repo. The next thing we did was create the PBJ text file. And if you remember, initially it had only this rough template inside. We then decided that we are ready to commit a version of this file, take a snapshot of the changes we made to the recipes repo. So we used the git add command to tell Git, hey, this file pbj.txt has some changes that we want to record in a commit. When we add a file, we also call it staging that file, because what Git is doing behind the scenes is add this file to the staging area, like this. So in the staging area, Git will make a record saying that during this time that we called the git add command, this file whose name is pbj.txt had this version. Okay, afterwards, we were ready to actually make a commit. We used the git commit command and provided some kind of a message. And we know that after we ran this command, a commit was created. We were able to see it when we ran git log. But let's also get a mental model of what happened behind the scenes. So we will represent a commit using these little circles. And we know that commits actually have longer IDs, but I'm just going to use simple ones in this video for now. So what happened when we made a commit is that the staging area got cleared and all the information that was in the staging area got added to this commit, like so. So this commit knows that at the time that it was made, the file pbj.txt had this version inside it. Remember that every commit also keeps track of all sorts of metadata, when it was made, who made it, what message was provided to describe it. Another thing that we get when we create the first commit is a pointer called master, which we will discuss later in this video. Another pointer that we get when we create the first commit is the all caps head pointer, and we will explain it in further detail also later in this video. Okay, after we made our first commit, we made a second file, and remember, we just copy and pasted the PBJ file, so this was its first version. We were then a little annoyed with the git status warning about this file being untracked, so we just went ahead and added it with this version. So note that this version is currently staged. Afterwards, we edited this file, and remember that Git was complaining that even though this file is staged, it has been modified. And how does Git know it? Well, Git can see what's inside this file at its current state in the recipes folder, and it also checks its staging area and its commits, or more specifically, the most recent commit. Well, Git can see, hey, I'm aware that eggs.txt should have this version at some point in time, but now the version that I actually see inside the file doesn't match the one that is currently staged. It also doesn't match what I have in my most recent commit, well, this file is not even tracked in the most recent commit. So this is how git status knows to alert us that x.txt has been modified. Well, at this point, we were ready to commit this version of the file, so we went ahead and added it again. The updated version is staged, and we were ready to make another commit. So let's see how this commit was made. The first step of making this commit is cloning the most recent commit, or the head commit. So we went ahead and did that. And you can imagine that at this point, this commit is tracking the exact same information as commit 0 did. Obviously, its metadata will be different. It has a different date, it may be made by a different author, and also with a different message. But the files and the versions it's tracking are identical to that of commit 0. Then Git will use the staging area to modify the new commit. So the staging area is cleared, and now this commit is also tracking the X file with this version. The last thing that happens is that we advance the master pointer and the head pointer to the new commit. Also note that commit 1 knows that commit 0 came before it. In other words, commit 0 is the parent of commit 1. Now we can also talk about what the master and head pointers are. So you can imagine that as we add more commits, this will look like a long chain of commits, or using the Git terminology, it will be a branch of commits. When we make a new Git repository, the default branch that we get is the master branch. And the master pointer always points to the tip of the master branch. So in other words, the most recent commit in the master branch. The head pointer always points to what the current branch is pointing at. So in this case, we only have one branch. This is master. It is possible to have multiple branches in Git, but we will not discuss this feature in this video. Another thing to note about the commit creation process is that the first thing we did was to clone commit 0. And this means that once a version of a particular file is committed, it will always be tracked by all future commits made. We use the staging area to change the version that a new commit and all future commits will track. And it is also possible to use the staging area to stop tracking a particular file altogether, using the git rm command, which we will not cover in this video. Let's see that process in action again. So after we created the second commit, we modified the pbj.txt file, and then we used git add star, which means stage everything inside the recipes folder. And remember that we only saw the pbj file getting staged, or more specifically, this version of the pbj file staged. Why did this happen? Well, Git looked inside its most recent commit and was able to see, well, the version that currently exists inside x.txt matches exactly what my most recent commit tracks. So no changes will be made for this file in a new commit. All right, we then called the git commit command to make a new commit. And let's repeat the process. We clone commit 1. We are still tracking the first version of pbj.txt. Now we will use the staging area to tell the new commit and all future ones that a new version is tracked for this file. Here we go. And the last step in making a new commit is advancing the pointers. So remember, master always points to the most recent commit in this branch, and head points to the current branch, which is just master. Okay, at this point, we saw how powerful Git can really be when it reverted our recipes repo to its initial state that was tracked by commit 0. We used the git checkout command, and again, the ID of this commit is not really 0. I'm just using 0 here for simplicity. Let's see what the git checkout command did behind the scenes. The git checkout command controls the head pointer. And when we say check out to this commit, we essentially tell Git move the head pointer to that commit. Git will then check what's inside the commit that the head pointer is pointing to. Well, in this commit, we are only tracking the fact that PBJ had this initial version inside. And it will then modify the recipes repo to match exactly the state of this commit. So we did not have the eggs file, and inside PBJ, we had that initial rough template. So you can think of the head commit as controlling what our repo looks like in the working directory. Remember that at this point, we got a warning from Git that we are at a detached head state. And this is because the head is currently not pointing to the tip of some branch. Here we only have one branch, the master branch, and head is obviously not pointing to the commit at the top of that branch. And this is what we call a detached head. Okay, after we checked out to a past state and explored around and got any information we needed, we wanted to get back to our most recent state that was recorded in commit 2, or in the tip of the master branch. To do that, we used the git checkout master command. So again, checkout controls where the head pointer points to, and now we tell it, hey, just point to whatever master is pointing to. There you go. And again, the same process repeats. Git will look at what this commit says the state of the repo should be, and will modify the actual current working directory of the recipes repo to match the state of that commit. Note that the checkout command actually changes what our current working directory looks like when we're inside the recipes repo. So Git will not allow us to check out if our repo is not in a clean state. Or in other words, we have some changes that are not safely tracked by some commit. Let's see that. Back in my recipes repo, I will hit git status, and we can see I get a clean status. Let's really quickly just modify one of the files. So I'm going to use the echo command. Let's say echo, I don't know, test, and greater than sign. You can think of it as like dump this string into, let's say, the PBJ file. So if we cat it now, we can see that it was added over here at the end. If you use only one greater sign, the file will be overridden, so cleared entirely and only get this text. Okay, so if we do git status, we can see that we don't have a clean status anymore. And let's see what will happen if I try to check out to an older commit now. So I can hit git log, just copy the ID of some commit, Q to go back to the terminal, always hit a lot of returns, and git checkout to this commit. And you can see that I'm getting this error. Your local changes to the following files would be overridden by checkout. So Git is telling us, well, this command will actually change the state of this repo, and you have some changes that are not safely committed somewhere, so please commit them before I go ahead and perform this dangerous command that will change things up. And ultimately, Git decided to abort and didn't actually check out to this older commit. Okay, so we are done talking about version control. I think we learned in these videos what is version control, how Git does version control, and what it does behind the scenes to operate the way it does. We also learned that it's time for me to become an adult and learn how to make food for myself, and I'll see you in the next video.